When filtering liquids, it's all about thinking small. Membrane filters can separate the tiniest solids from fluids, which purifies the liquids and recovers the solids. Once separated, the two substances may then be reused, so that nothing goes to waste. Membrane filters can turn murky water clear, almost magically. To demonstrate, a technician installs a spiral-wound membrane in the housing of a pumping system, which is a small-scale version of what you would see in a factory. She turns on the tap and water flows into a tank. She adds latex paint to purposely sully the water. The system pumps the contaminated water through a strainer, and then the membrane filter, while meters measure the flow. Within minutes, the paint has been filtered out, and the water is clear. The making of a membrane filter begins with polypropylene mesh. An automated system unwinds the mesh and cuts it to length. These mesh sheets will be used as spacers. They'll create gaps for the liquid to flow through the filter and over the membrane. Next, the system cuts sheets of polyester fabric. These will form channels through which the filtered material will travel. These sheets are known as permeate spacers. An employee stacks the polyester fabric sheets. Using high-frequency sound waves, she welds one sheet to the next at just one end. She layers and welds a total of 15 sheets and then applies double-sided tape. The tape is for attaching the packet to a central tube, and it will also serve as a guide to correctly align it. Next, the membrane soup flows into a long trough. It's a mix of melted plastics and solvents. Paper backing unwinds into the trough and is coated with the soup on one side. The coated paper then travels through two quench tanks, and the plastic components solidify as the solvents are drawn out. The exiting solvents create a unique pore structure in the remaining white plastic membrane. The membrane now travels by a light box, which illuminates any visual defects. An applicator also drips a preservative onto the membrane. A team unrolls the membrane onto a work table. They lay a sheet of the polypropylene mesh, which we saw cut to size earlier, on the membrane. The employee then cuts the membrane to twice the length of the mesh. They fold the membrane over the mesh, creating a membrane envelope. The mesh serves as a pathway for fluid to flow between the membranes. Meanwhile, another worker applies epoxy to a perforated plastic tube. He attaches the permeate spacers to it with a double-sided tape, giving the epoxy time to cure for a permanent seal. He and a colleague apply more epoxy to the perimeter of the bottom sheet. They transfer the membrane envelope to it and continue to layer, making a permeate fabric and membrane sandwich. The worker then winds the glued layers snugly to a perforated plastic core, forming the spiral membrane filter. He tapes the multi-layered wad from one end to the other. The tape holds everything tightly in place as the epoxy cures overnight. They leave the tape on after the cure, and the machine winds epoxy-drenched fiberglass rope around the entire filter. As the epoxy cures, the rope will form a hard shell around the membrane filter. Partway through, they apply the label with the company name. The operator captures the glue runoff during the wind. And it's a wrap, so he cuts the rope. From the side, you can see the flow channels between the layers. Concentrated contaminants will travel through them and out. The filtered liquid will seep into the core and exit, clearly improved.